So far in our series of videos on correlation analysis, we discussed about the computation of correlation coefficient for a set of data which are often expressed quantitatively. Carl Pearson's product moment method is more than handy to handle such situation. Pearson's method of correlation is relevant whenever the given data follows normal distribution or whenever the two variables are linearly related to each other. Under that situation, we can rely on Pearson's correlation method. However, we may encounter a situation wherein we are interested in finding correlation between two variables which are qualitative in nature, or whenever the data that do not follow normal distribution. Spearman's rank correlation is one such widely used technique to assess the correlation between the ranks assigned by an individual on a qualitative factor. We will be discussing about this non-parametric methodology to calculate correlation coefficient in this video. And therefore, I welcome you all to Avi's Academy, and if you are a first timer to my channel, please click the subscribe button and press bell icon to get continuous updates on the videos which I am going to upload in future. First of all, let me list out three questions. The questions are: what is rank correlation, what it measures, and how to ascertain its coefficient. The answer to these three listed questions will help us to understand the concept of rank correlation in a better manner. To speak about the first question, what is rank correlation? Rank correlation is a non-parametric measure of strength and direction of association that exists between two ranked variables. So in this meaning or definition, there are some certain specific terms that we have to analyze so that we can understand what rank correlation is. The first term that comes into picture is non-parametric measure. To learn about non-parametric measure, what is non-parametric measure? First of all, we need to know what is a parametric measure. So parametric measure expects that the data which we use it for analysis, it has to resemble a particular distribution. Usual expected distribution is bell-shaped distribution, that is normal distribution. If the data which we are using it for analysis, if it follows normal distribution, we use parametric measure of statistics for analysis purpose. In the case of correlation analysis, if the data we use follows normal distribution, we usually use Carl Pearson's product moment method to measure the association between two variables. But if the data do not follow normal distribution, we go for non-parametric measure. There are different non-parametric measures available. One of the popular measure is the rank correlation, Charles Spearman's rank correlation measure. Now speaking about the non-parametric measure, I can say it is distribution free. Nothing but it do not make any assumption about the distribution the data should follow. They are distribution free, and therefore we can apply non-parametric measure to any kind of data. It could be nominal, it could be ordinal, or even it could be interval scale data. So whenever the data do not follow normal distribution, we go for non-parametric measure. So rank correlation is a non-parametric measure of strength and direction of association. Just like Carl Pearson's product moment method, Spearman's rank correlation also measures strength and direction of association that exist between two ranked variables. So another term which is important here is ranked variables. So in case of Pearson's correlation method, we use actual data to calculate correlation coefficient. But in case of Spearman's measure, we do not use actual data. We use the ranks of the actual data to calculate correlation coefficient. So that's why it is called as it is the association and strength and direction of association between the two ranked variables. Variables will be given, its values will be given. We have to rank these values, and after that, using the rank, we have to calculate correlation coefficient. That's why it is called as rank correlation measure. So this is what rank correlation is. Now coming back to our second question, what it measures, what rank correlation measures. Rank correlation measures strength and direction of monotonic relationship between two variables, whereas our Carl Pearson's correlation measures linear relationship between two variables. So monotonic linear relationship, what it is, if you want to know more about this, I'll make a separate video on this monotonic relationship, so you can watch that video. Now just to say what correlation coefficient of Charles Spearman's measures, it measures monotonic relationship, not linear relationship. Remember this. To discuss about our last question, how to ascertain its coefficient. In ascertaining coefficient of rank correlation, we have to rank the variables given in our question. So once we rank the variables, there may be two situations that may occur. One situation is when there is no repetition in ranks. Another situation is when there is a repetition in ranks. When there is no repetition, we use a simple formula to calculate the rank correlation. Rank correlation is usually denoted using the Greek letter rho, or we can use R subscript S to denote rank correlation. So R subscript S is equal to speak about the formula, that is 1 minus 6 sigma d square divided by n into n square minus 1. So this is the equation we follow whenever there is no repetition in ranks. However, whenever there is a repetition in ranks, we make some correction to the correction at the time of allotting the rank. So this correction will be included as a correction factor in our previously discussed equation. We make a modification to the equation and then we calculate rank correlation whenever there is a repetition in ranks. Under this situation, we calculate rank correlation using the formula R subscript S, that is rank correlation is equal to 1 minus 6 within bracket sigma d square. To this value we add a correction factor, so it is 1 minus 6 into sigma d square plus correction factor divided by n into n square minus 1. So this is the equation which we use to calculate rank correlation. Thank you guys for watching the video. If you like this video, do consider to subscribe to the channel and press bell icon to get future updates on the videos which I am going to upload. Thank you for watching.